Hello students, welcome to lesson 2, chapter 8, Introduction to Trigonometry. In the last lesson, we have started studying basics of trigonometry, that is 6 trigonometric ratios, etc. First, let us recall what we have studied so far. See, we have defined 6 trigonometric ratios like this. Consider a triangle ABC with the angle B 90 degree. Then if you take angle A, BA is called adjacent side and BC is opposite side. Then of course AC is hypotenuse, angle opposite to side opposite to right angle. Now sin A equal to opposite side by hypotenuse. See, what is important here is don't remember the formula in terms of ABC etc. because it may change anytime. But the basic definition of sine is if you take A as the angle of a right angle triangle, then sine ratio is opposite side of that angle A divided by hypotenuse. Similarly, cos A is adjacent side of A divided by hypotenuse, and tan A is opposite side by adjacent, and cosecant A, which is the reciprocal of sine, hypotenuse by opposite. Then secant A, that is hypotenuse side by adjacent, and cot A is adjacent side by opposite. And I also made it clear we are using abbreviation here. Actually it is a short form, sin, sine, cosine, cosine, but we write cos, then tangent, tan, cosecant, cosec, then secant, sec, and cot, cotangent. So these are the full form. So these are the 6 trigonometric ratios. Then we have also studied the relationship between different ratios. The first one is sin A into cosec A equal to 1, or you can also write sin A equal to 1 by cosec A and cosec A equal to 1 by sin A. Same way, second one is the second pair cosec A and sec A, so that is equal to 1, and cos A equal to 1 by sec A and sec A equal to 1 by cos A. So this is the second pair, cos A and sec A. And the next one is tan and cot, tan A cot A equal to 1, then tan A equal to 1 by cot A, and cot A equal to 1 by tan A. So these are the basic ratios and their relationship. But then there is one more relationship. See, tan A is also equal to sin A by cos A, and cot A equal to cos A by sin A. So these are the basic relationship which you have to remember. Now in this lesson, let us work out a few examples based on trigonometric ratios and their internal relationship. First question, if tan A equal to 4 by 3, find the remaining trigonometric ratios. So given tan A equal to 4 by 3, let us take a triangle ABC where B is 90. Therefore tan A equal to opposite by adjacent. This is the definition, and that is equal to, now according to the diagram, it is BC, opposite side is BC, and divided by AB. AB is the adjacent side. Therefore what we have to do is take BC equal to 4A because it is opposite side. Adjacent side you take as 3K. Therefore one is 4K, another one is 3K as shown. AC, which is the hypotenuse, will be equal to AB square plus BC square, Pythagoras Theorem. So substitute, that will be 3K square plus 4K square. When you simplify, you get 25K square because 3K square is 9K square, 4K square is 16 K square, 16 plus 9 is 25. When you take square root, it is 5K. Therefore AC is 5K. So now look at the triangle. All the three sides are given. AB is 3K, BC is 4K, and AC is 5K. Therefore now we can find all the remaining trigonometric ratios. So now sin A equal to, we know the definition, it is opposite BC divided by hypotenuse AC. Therefore substitute, it is 4K by 5K. K can be cancelled, so it is 4 by 5. Similarly, cos A equal to definition adjacent, that is BA divided by AC. Substitute BA is 3K divided by 5K. Cancel K, you get 3 by 5. Similarly, cosec A cosec A will be equal to AC by BC, hypotenuse divided by opposite. Therefore, that will be equal to 5K by 4K. Cancelling K, we get 5 by 4. You can see sine and cosec are reciprocal, 4 by 5 and 5 by 4. Similarly, we can find sec A, that is equal to AC by BA. So, it is a reciprocal of cos. So, 5K by 3K. So, which is 5 by 3. And the last one cot A, which is reciprocal of actually tan, that is BA divided by BC. So it is 3K by 4K, cancelling K again 3 by 4. Thus, given one trigonometric ratio, we can always find the remaining 5 trigonometric ratios like this. So this is the first question. Question 2, example 2. If B and C are acute angles such that sin B equal to sin Q, show that B equal to Q, show that triangle ABC and triangle PQ are similar. Now let us consider two triangles. One is ABC, another one is PQR. But condition is both B and C are acute. Therefore, but condition is sin B equal to sin Q. Sin B equal to sin Q. So in triangle ABC, angle A is 90 as shown, and in triangle PQR, angle P is 90 degree, because other two angles are acute angles. Therefore, now what is given? Sin B equal to AC by BC by definition, and sin Q will be equal to PR by QR. PR by QR. So this implies AC equal to AC by BC equal to PR by QR, because sin B equal to sin Q. So this implies, and angle A is 90 degree, angle P is 90 degree. Therefore, triangle ABC and triangle PQR are similar. So by criteria, we have studied this in geometry. So now, if the corresponding triangles are similar, corresponding angles must be equal. What are the corresponding angles? B and Q are corresponding angle. Therefore, they are equal. Of course, that I have not written. That you can write. Therefore, B and Q are equal. Next, example 3. In triangle ABC, with C equal to 90 degree, AB equal to 29, BC equal to 21, and angle B equal to theta, find sin square theta plus cos square theta. That is first part. Second one is cos square theta minus sin square theta. What is given is, in triangle ABC, let's see, this is the triangle ABC, C is 90. So now, second one is AB equal to 29. So AB is actually hypotenuse, that is equal to 29. And one more is BC is 21. So BC is 21 as shown in the diagram. Now B is theta, angle B is theta. Now what you have to do is, AC we have to calculate. Now use Pythagoras theorem. AC side will be equal to AB square minus BC square, of course under square root. Therefore, this will be equal to AB is 29. So 29 square minus 21 square. Simplify this, it is 400 square root of, and the square root of 400 is 20. Therefore, the opposite side AC is 20 units. So now you know all the three sides. One is 21 BC, opposite side is 20, and the hypotenuse is 29. Now sin theta we have to calculate. Definition is opposite, that is AC divided by AB, that is equal to 20 by 29. Similarly, cos theta will be equal to adjacent BC divided by AB, and that will be equal to 21 by 29. Now we have to calculate. First one sin square theta plus cos square theta. Second one cos square theta minus sin square theta. Now sin square theta plus cos square theta equal to 20 by 29 square plus 21 by 29 square. This you have to simplify. This will be 400. 20 square is 400 divided by 841. 29 square is 841. Plus second one, 21 square is 441 divided by 841. When you add, what do you get? 841 by 841, which is equal to 1. In fact, this is called an identity which you are going to study. Sin square theta plus cos square theta is 1 for whatever may be the value of theta. Second one, cos square theta minus sin square theta. Of course, we have already determined what is cos square theta. That is 441 minus 841 minus sin square theta is 400 by 841. Therefore, it is 41 by 841. So, these are the two values. This is example 3. Next, example 4. In triangle ABC with B equal to 90 degree, if tan A equal to 1, verify that 2 sin A cos A equal to 1. We have to actually prove it. Now, consider the triangle ABC. What is given is, in triangle ABC, B is 90 degree. B is 90 degree. Now, tan A is 1, that is given. But this implies tan A equal to, what is the definition? It is BC, opposite side, divided by AB. So let us take this as, but that is equal to 1, that is given. This implies BC must be equal to AB, because BC by AB equal to 1 means BC must be equal to AB. Let us take it as K, because both are equal. Therefore, both sides BC and AB, they are K and K. And it is a right angle triangle. Therefore, what we have to do is, we have to calculate the hypotenuse AC. You know that AC equal to square root of AB square plus BC square, Pythagoras Theorem. Therefore, that is K square plus K square, because AB is also K, BC is also K. So, this is 2K square or K root 2. K root. Therefore, AC is K root 2. So now we know all the three sides in terms of K. Now find sin A. What is sin A now? Opposite by adjacent, hypotenuse. Opposite is BC, divided by hypotenuse is AC. Substitute. That is K. AC, BC is K, divided by AC is K root. Cancelling K, we get 1 by root. Same way, cos A equal to AB by AC. What is AB? AB is K, divided by AC is K root 2. Once again, cancel K, you get 1 by root. Therefore, sin A is also 1 by root 2. Cos A is also 1 by root 2. Now, substitute 2 sin A cos A equal to 2 into, first one is 1 by root 2 into, second one cos A is also 1 by root. What is 1 by root 2 into 1 by root 2? It is 2. 2 numerator, 2 denominator, 2 into 2 cancels. Therefore, it is definitely 1. This is what we wanted to show, verify. This is example 4. Let us proceed. Example 5. In triangle OPQ, right angle at P, that means P is 90 degree, OP is 7 and OQ minus PQ equal to 1. Find the value of sin Q and cos Q. See, let us first draw that triangle so that problem will be understood. In triangle OPQ, so this is a triangle. What is given is P is 90, because it is right angled at P means P is 90. So I am marking angle P. Now what is given is OQ minus PQ equal to 1. OQ, that means hypotenuse, minus PQ, that is opposite side. So difference between them is 1. So this is one thing. Second one is OP is 7. Hypotenuse is 7. So sorry, not hypotenuse. Another side, that is opposite side of Q, that is 7. So that is given. Therefore, now what we do is OQ minus PQ equal to 1 means OQ can be written as 1 plus PQ, that is taking PQ right side. Now let us square it. So OQ square will be equal to 1 plus pq square plus 2pq a plus b whole square. So right hand side 1 square is 1, pq square is pq square into 2pq. So a plus b whole square formula. Now that is, here we have to use one more thing. What is OQ square? OQ is hypotenuse. Therefore, OQ square will be equal to OP square plus PQ square. Therefore, this I am substituting the left side. So, OQ square will be equal to OP square plus PQ square, and that is equal to right hand side 1 plus PQ square plus 2PQ. Now here what happens is PQ square cancels. So you get OP square will be equal to 1 plus 2 into PQ. So this is the first thing. But now what is OP square? OP is 7. Therefore 49 equal to 1 plus 2 PQ, because OP is 7. Left hand side we can write 7 square, which is 49. Using this we can find PQ. Therefore 2PQ will be equal to 48. That is 1 you can take left side. So 2PQ equal to 48. Or you can write PQ equal to 24. So PQ side is 24. Now what is OQ? OQ is equal to 1 plus PQ. Therefore substitute PQ. So 1 plus 24, 25. Therefore now we have these things. Look here. OQ is 25. Then OP is already given, that is 7. And PQ is, we have determined it already, 24. So all the three sides are given. Now what is asked in the question? Find the value of sine Q and cos Q. Therefore now sine Q equal to OP divided by PQ, OQ, that is 7 by 25, and cos Q equal to adjacent, that is PQ divided by OQ, that is 24 by 25. So these are the values. So thank you students. Hope you appreciate this way of solving the problem. See, trigonometry is a very simple, very interesting branch, and please note, if you are continuing your study in mathematics by taking science, trigonometry is the basic foundation for higher mathematics. Therefore, please study them properly. But as I told you, to understand trigonometry, you should be thorough with algebra and geometry also, because frequently we are using a similarity concept, then right angle triangle, Pythagoras theorem, so many other things. Therefore be prepared with algebra and geometry. Definitely will be enjoying this chapter, because it's very interesting. In the next lesson, let us continue with solving the problems given in the exercise. And then there are some basic, very simple properties, for example complementary ratio, some basic identities, etc. Let us study in the future course of our study. Please subscribe if you have not yet subscribed, and share with your friends. Please watch all the lessons, so that definitely your study will be very, very useful. And watching this video will definitely help you to understand the concept very clearly. I am taking almost all types of problems. Only similar problems I am leaving for you to practice. Let us meet in the next lesson with the exercise. There are many interesting questions. Let us see them. Till then, bye. Take care.